Welcome back, learners. So in the previous lecturing video, we have in detail learnt about how to develop the beams in the ETABS software. Now before I move on to the defining the slab and assigning the slab for the given problem and application of the load, we have to understand the orientations of the column, which is important. Now, why the orientations of the problem plays a very important role? You may have the question. Now, especially when it comes to the columns which is circular in nature or which is square in nature, the orientation of the problem doesn't come into play. The orientation of the problem doesn't come into play because in circular columns or in the square column there is no any major bending axis or minor bending axis. Both axes are of same nature. There is no any differentiate between the major bending axis as well as the minor bending axis. But when it comes to the rectangle column, you have particular two axes. So one is the major bending axis and another one is the minor bending axis. So positioning the column or the orientations of the column when it comes to the rectangular column plays a very important role because of the presence of the major bending axis and minor bending axis. Now when the column is placed with respect to the minor bending axis, definitely the moment of inertia of the column will be low. Okay, the moment of inertia of the column will be low, so leading to less safety. But when I made the column to bend along the major bending axis, then definitely the moment of inertia will be high, then you will be on the safer side. So due to that reason, orientations of the column plays a very important role. That is one reason. Along with that, the another important reason that why you have to orient the columns properly is in order to avoid the eccentricities. In order to avoid the eccentricities, it means especially when it comes to the residential building, you have to avoid the orientations of the columns in such a way that it should not come out of the wall. Okay, it should not come out of the wall, because it will affect the architectural appearance or the pleasant appearance inside the houses. So if the column projections are present outside the houses, no issues, but if the column projections are present inside the houses other than the walls, if it covers along with the walls, then it is a very good orientation. So like that, keeping these two concepts in mind, we have to arrange the orientations of the column. Now let us take this plan. Now we have oriented all the columns from left to right, that is along the x-axis we have the column orientations. Now let us check whether those orientations are suitable for that particular column position or we have to change. One thing you have to keep it in mind, students, that from one position of the column to another positions of the column, there will be an always change in the orientation. Okay, so there is no rule that if I change one column orientation, then the another column orient also has to be changed. No, it is not like that. You can, even every column may have its own different orientation. Now let us see, since we are changing the column for all the floors, so instead of making the one story, I will make all the story. Okay, yes. So now let us start from this column itself. Now when I consider this column, now let us see a student that if I orient this column like this, that is along the x-axis. Now what is the issue? You can see that outside the building you have an eccentricity of this column. okay, which is not good because it won't give the pleasant appearance. Okay, so let us keep that reason aside because anyhow it is outside. But what about the stability? Always keep one critical point in mind, students, that try to orient the columns in such a way that the maximum number of primary beams or the mother beams should be along that column. It should not be joining to that column perpendicular to that orientation. It means, for example, if I see this, for this one, this is my mother beam because I am connecting this with another column, whereas this is my secondary beam. And not only that, you have a cantilever projection also. So therefore, the more loads will come to this column from these two beams corresponding to this beam. Therefore, if I change the orientation, that will give the more stability, and not only that, this eccentricity of the column will be avoided. And since when you are placing like this, so this column will have in continuation with these two walls. Only this wall, definitely it will come and join, that will not create any issues. So therefore, instead of keeping like this, if you select and if you change the orientation, that will give you a better option. This is column 3. What I will do, I will just select this column, I will delete this. Then I will go to column. In that I have to choose column number 3. Okay, I have to choose column number 3. Okay, I have to choose column number 3. Now you can see here, this column number 3 is now right to left. Now I have to make it to in the another direction. Now if I want to change the orientation, then what you are supposed to do? Can you see here, student, that in there itself you have an option called angle. What we call it as angle in degree. There initially it was 0, therefore it is coming from left to right. Now when I made this angle to 0 to 90 degree, and when I enter it, you can see that my column orientation has been changed. Okay, my column orientation has been changed. So therefore now this is the most suitable orientation, right? As I already told, there will not be any eccentricity. This wall and this wall will be in continuation with this column, as well as since the more loads are coming from these two beams, they are along with this. So this, it can easily come and sit at the center of the beam. So therefore no issues with this column, the orientation is changed. Now similarly, in the same manner, here also it is better to change my orientation. Why? You can see this is my main beam, even this is also my main beam. Okay, but since there is a cantilever here, so better I have to change. And not only that, you know, this is the utility area. If I place like this, then again this part will come out. This part will come out from the wall, which is not good. So therefore better I have to orient this, and even I will change the orientation of this. And not only that, even I will change the orientation, because this will also create eccentricity, because here there is no any beam or no wall. So if this wall comes the projection, then again it will disturb the appearance. So therefore I will change this, even I will change the orientation of this also. Okay, like this. So therefore let us change all the 4 orientation. Therefore I will select this, I will select this, I will select this, I will select this, I will just delete them. Then I will go to the columns, column 3. Now here, 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 right? So now the column orientations are proper. Now my column orientations are proper, right? Okay, so this 4 column orientations is done. Now let us come to this now. Now when it comes to this, again it is better to orient because this is also main beam, this is also main beam, okay, but the length of these two beams are very higher where compared to this. Therefore, we need to have more, that is major bending axis in this direction. Therefore, let us orient this beam, this column in that direction. Therefore, I will just delete them, then I will just take and I will orient like this. Okay, so this is also done. Then let us see these three. Let us see these three columns. So now when it comes to this column, the orientation of this column is proper. Why? You can see I have one beam here which is main beam, I have another beam which is here main beam. So both the beams are going to join to this column, therefore the orientation is like this. If I change the orientation, then again here you will get an eccentricity. Here you will get an eccentricity. So now this wall and this wall will get continuation with this column. So therefore this orientation is better, and this column anyhow it is not a main beam, it is a secondary beam. So therefore this column orientation no need to change. Then what about this column orientation? So that column orientation is also nice because this is main beam, this is also main beam, all are in continuation with this, so therefore no need to change. Okay, and this is this, if you want you can change it to this direction because it will create an eccentricity here. So therefore we will rotate and we will keep like this. So this is column number 2, right? This is column number 2. Delete here. So column number 2, right? Yes. So that I have now I have to make it to, already it is 90 degree, I have already changed the angle, so 90 degree, right? Yes. These 4 beams are now okay. Now when it comes to these 4 columns, now again this better to orient like this, okay, because this will create eccentricity here also, here also. Even if you make like this, eccentricity will be there, but since this is main beam, so better we will connect like this. So therefore I will select this, I will delete this, then I will go to this and I will place like this. Then what about this? This is proper because this is main beam, this is main beam, it is connected. Okay, okay. And even if I rotate like this, then you know this area will be utility, so that will create eccentricity which is not good. So therefore let us keep the column like this only. Okay, but this column definitely I have to change it to this direction because you know this is a very large beam coming here, this is a long beam, so and even this will create a lot of eccentricity. So therefore we will rotate and we will keep in this direction. Okay, so therefore what I will do, I will change the orientation of that, this one to here. Okay, yes. So therefore all 3 these columns are proper. Okay, all these 3 columns are proper. Now let us see this. So this, so better I will orient in this direction. Okay, so this let us keep as it is, but this again I will orient in this direction. So this I have to edit, delete, I have to choose column number 2 and I have to place here. Similarly this is proper, so this I have to delete this, okay. So I will delete this column, but now I have to make to column number 3 and I have to place like this. Okay, I have to place like this. Yes, so then yeah, so after that these three columns are over. So now let us see. So this is perfect, no doubt, because here as well as here, so the column lengths are of larger line, so this is okay, but this I have to change. Okay, so this I have to change because this is of larger length compared to this, so both the loads will come here, therefore, and even this will create an eccentricity here, therefore I will change it to this orientation. This is perfectly proper. This orientation is perfectly proper because it is a square column, so no issues will come. This I have to change. So therefore what I will do, I will select this, edit, I will delete this. So this one I will make like this. Okay, yes, so this is okay. Now similarly this orientation is also okay. This again I have to change it to this direction. So therefore I have to select this, I have to delete, I have to bring it to this orientation. So here no issues, here also no issues, but again these two again has to be oriented in the other direction. Okay, these two has to be oriented like this. So therefore I will select this, I will select this, edit, I will delete this, then I have to select and I have to place these two columns like this. So like this, therefore column orientation plays a very important role. Okay, column orientation plays a very important role. So once the column orientation is done, our next step is we have to model the slab. Okay, we have to model the slab. So once the modeling of slab is done, so then what we have to do, we have to assign the slab. So how to model the slab and how to assign it, so that we will see in the next video. Once the modeling of slab and once the modeling of defining the slab and the modeling of the slab is done, then in the next video we will see how to apply the loads. Before that, students, I wanted to make you one point very clear, that when I go to the bottom, that is to the foundation, that is this level, you can see this are considered to be the points of foundation in the software. For example, when I make it 3D, you can see here these are considered to be the points of the foundation. Now when the image was like this, the software will consider this as an hinge support. Okay, it means the column can move or the column can rotate, but in the practical cases the column will be considered as the fixed support. We are not considering it as a hinge, or we are not considering it as a roller. That means we are not considering it as a pinned support, we are considering it as a fixed support. Therefore all these joints whatever is there, that we have to make it to fixed. Then how we are supposed to make this? So keep it in mind, this joints has to be made only fixed only at these points. I don't want all other joints to be considered as fixed. I want only these joints, that is the support conditions, to be considered as fixed. So for that, first what you do, you just make it to one story. Okay, then go to plan, then go to base, then give apply, okay. Then select this all the points like this. Select all the points and you can see it in 3D that only those bottom points are selected, not other joints are selected, only the joints of the foundations are selected. Okay, so once they are selected, then what you have to do, you have to go to assign. you have to go to assign. In assign, okay, in assign, what you are supposed to do, you are supposed to go to joint. Okay, in assign, you are supposed to go to joint. In the joint, you are supposed to go to restraints. You are supposed to go to restraints. Now you can see here that based on whichever you are going to select, so based on that, the joint will act as a pinned or a roller or a hinge or a fixed. You can see here there are easy options. So if I select this, then you can see here all my transition along x, that is movement along x, movement along y, movement along z, then rotation along x, rotation along y, rotation along z, everything will be restrained. It means we are not allowing the foundation to move in xyz direction. We are not allowing the foundation to rotate in xyz direction. That is what the meaning of this. That is nothing but your fixed. If I choose this, you can see that only the transitions are restrained. That is nothing but it becomes your hinge support. In the x direction it is not allowed to move, in the y direction it is not allowed to move, in the z direction it is not allowed to move, but they are allowed to rotate in x, y, z direction. It means it acts as a hinge. Okay, if I select this, now we can see that I am allowed to move only in the z direction. Okay, it acts as a roller, right? It means when you select a roller, the roller can move in the x as well as in the y direction. It can rotate in x, y, z direction, but it cannot be moved in the in the z direction. So therefore, the only z direction is selected, all others automatically will get unselected. If I choose this, it is a hinge, rotations are allowed, no movements are allowed. When I select fixed, all are not allowed. Here only rotations are allowed, movements are, that is translation motions are not allowed. Here translation motions are also allowed, but not in y direction, that is in the z direction, that is in the vertical direction, and rotations are allowed. And when I select this, it is nothing but a simple support where all the rotations as well as all the translation motions are allowed. But as I already told, when we are designing a foundation, we are making it as fixed. Therefore, I will select the fixed, then I will give apply, then I will give OK. Okay. So now if you see the 3D structure, now this system has been changed. Initially the view which was showing was different. Now the view which is showing is different. Now it is very clear that we have made it to the fixed support. Now it is ready. Okay. Yes. So now in the next video we will define the slab, then we will assign the slab, then we will apply the loads as per the IS codes. That let us see how to do that in the next video. Thank you, learners.